Welcome to Work Life Cyber. Today we are going to continue in domain 1 and we're going to talk about still talking about security concepts. Today we are focusing on cryptography. And cryptography is simply a way to hide information so that only the intended person can read it, right? So I'm sending you a message. Now I am going to encrypt it in a way that once it gets to you, you are the only person who can read it. I am sending it to you encrypted. If it lands anywhere else, nobody can read it but you. It has to come to you because I have given you a key to unlock it. So we are going to talk about how cryptography and what it involves. One thing is public key infrastructure, which you will see a lot as PKI. Don't mess it up with KPI. This is public key infrastructure. So every time you see public key infrastructure, know that it is a way to hide or code information. It involves a public key and a private key. I know the name says public key infrastructure, but it does involve a public key and a private key. That if I send you, if I am locking it with one key, you best believe that I have given you another key to unveil or unravel or reveal what I am sending to you, so that if it appears anywhere else, no one will be able to read it or see it. The main function of cryptography is to ensure availability, the triad. So let's do the CIA: the confidentiality, integrity, and availability of information. Confidentiality, as you may know, that no one can see it unless they have the key to unveil it. Integrity, because once you see it, you can't even change it, or you can't say you didn't see it, because we will know that you've used the key that was provided to you to unveil it, right? And then availability, because even if you delete it, I still have the key to show or prove that I sent it to you, you have it, or because I sent it to you, I have a key to provide what I sent to you. Again, I hope this makes sense. So now let's talk more about how cryptography is actually done, what algorithms are used. It's just an algorithm or a code just to hide information from unauthorized users or unauthorized personnel or unauthorized people. All right. Now let's talk about public keys. Cryptography uses two keys: public keys and private keys. Now we are going to talk about public keys, and as the name suggests, public. It doesn't mean that it's available to anybody. It just means that me, the one who is creating it or sending it, is sending it to a whole bunch of people. I'm sending it to the public. I'm giving it to everyone to see it, everyone that I choose, a whole bunch of people. I can decide to just show it to the whole world, but that's what the name is. Public key. It's just a public key and public key that I send out to majority of people to unveil or unravel, not unveil, unveil or reveal what I am sending to them. Even though I am protecting it, it's still a form of encryption and it's still safe. Every public key has a corresponding or a linked private key to it. And private key, just keeping it simple, is also a form of encryption, a form of a key to encrypt and decrypt, but it's private. If I am sending it to you, you are the only one who will be able to see it. You're the only one who will be able to unveil it. You're the only one with the key. I am giving it to just this key. It's a private key created for you to see the information, for you to unravel the information, and we can go back and forth, just you and I. It is private. It is not public. We're not unveiling it to everybody who can just read the information. If an information is open to you, you best believe you have the key to view it, to access it, right? So there's private key and there's public key, and these keys are used to decrypt and encrypt information, and it's also used to protect information from being accessed by unauthorized people. Still under encryption and the security concepts, I'm trying to explain, give you a lot of definitions So just stay with me. Don't lose guard. We are talking about definitions and concepts. Let's talk about key escrow, still under encryption. Key escrow, you've learned private keys, you've learned public keys. Now we're doing key escrows. You have all these keys, you have all these codes, right? And remember, these are actual codes that you go into a coding console and do it. So if for the purposes of passing the exam, let's learn these concepts. Most of you will not have to create public or private keys. You will not have to go into any system and create policies that require keys. So just learn it for the exam. You do need to pass the exam. So now let's talk about key escrow. You have all these public keys and private keys. Key escrow simply means a place to save all of these encrypted keys, all of these private keys you have, all of these public keys you have. So key escrow is a way to save or gather or compile private and public keys. So it's like a container, right? Maybe people who actually code will say, no, it's not a container. It is a container. I'm talking about just virtual container. Don't think too much about where you save your codes. Okay, actually it's the same thing. But the main point is that this is a place to store keys, encryption keys, private, public, all the keys you have. This is where you will store it, right? So when you see key escrow, just think storage. Think a hub, a place where you put codes, private, public encryption codes, a container, a bucket for these things, for codes, okay? Now let's talk about data at rest. Data at rest, encrypting. We're still talking about encryption, so don't lose guard here. Data at rest, you need to encrypt your data at rest. If the data is stored, you need to encrypt it. At my workplace, when I go online or when I go into any of our files, I have access to it because they have given me the access, but it is encrypted. If you don't have any access, like my email is my access, they have given me that because I am an employee, I still don't have access to every file in our company. I only have access that is given me. So data at rest is you encrypting the data that is stored. Remember, some of these data, you may never look at it again, or you will look at it once a year, 2 or 3 times a year, once a week, once a day. But once you're not using it, it's just resting. It's just there, right? But whilst it is there, not anybody can just access it. The fact that we're not using it, the fact that we've just saved it to use it tomorrow or in 3 hours, doesn't mean that it's left there for threat actors to access or unauthorized people to access. It just still must be encrypted so that when you come in and you're not an authorized person, you will not be able to. Sometimes you go to a place, you click on it so many times, it won't open. And sometimes when you see SOC reports, you scroll down and you only see one page, and that's because you don't have access to it. Even though it's saved, it's 3 years ago SOC report, you still don't have access to it because it's encrypted only for authorized people to access, you see. So data at rest needs to be encrypted, okay? Another thing that needs to be encrypted is data in transit. Data at rest is when you've saved it and stored it. It's sitting there for whenever you need it. Data in transit is anything that is being sent over the network, over any network, over emails, over the cloud, anything. And this actually prevents packet sniffers. You see, they will catch the information before it gets to the sender, and then they will use it against you, or they will intercept. It will prevent interception as well. So what happens here is that whilst you're sending information, whilst you're saving it, where it's going over the network to save. If you work in any place that uses OneDrive, or once you're saving it, you see that it circles a little bit before now it saves. whilst it's circling and trying to save and gather all the information, data in transit. You see, when you're sending it over the network to anybody in the company, over the network to anybody outside the company, during the transit, when you hear transit, it means movement. So you're encrypting it whilst it's movement. And this, again, prevents packet sniffers. In case it is snatched on the way, they will still not be able to open it. It will be basically useless to them because it is still encrypted. All data, and again, you are not going to be the one encrypting it. There are professionals for this and they do it. They've studied it. And so most companies have data at rest, encryption for data at rest and data in transit. In fact, some assessment will ask the person who is receiving the assessment whether they, either the application owner or a vendor, if their data is encrypted at both at rest and in transit. Now that we've mentioned these two data points that need to be encrypted, or some of the things that need to be encrypted, let's talk about the levels of encryption. Yes, there are levels. Sometimes when you go into a folder, you see that, or you go into a website, you see that you can click these areas, but these areas are grayed out that you don't have access to. And sometimes, like if you go to your medical portal, any hospital portal, you see that, okay, you can see this, you can see that, you can see this, but some of them, they will say provider information. If you're a doctor, if you're a practitioner, then put a code in before they give you access. All these are forms of encryption. So next, we are going to talk about the levels of encryption. Stay with me. I hope you're not confused yet. So there is full disk encryption, there is full volume or full file encryption, there is partial encryption, partial file encryption. Full disk encryption, as the name is that the entire disk is encrypted. So meaning when it's given to you and you don't have the key to access it, you will not be able to see anything on the disk. But if it's a partial encryption and I give it to you, you will see some folders on the disk that are maybe public, that you can see, but there will be other ones that you would have to actually decrypt to see it. And then there is full volume or full file encryption. This means even after you've accessed the disk, you will still have folders in there that maybe you click on the folder and there are files in there that you can access those files, but some of them you won't be able to access it. What companies do is that there are files that are public or basic information that even if a threat actor sees it, it won't cause any harm. And then there are files that maybe personal information is on it or very important coded information are on it. And so they don't want just anybody to see it, but people with authorization can see it. And those people already have a code to decrypt. So full disk, partial disk encryption, and full or partial volume or file encryption. So when you hear file, just know that you are able to get into the disk, but when it's a file, you only see part of the file or some of the files, and you don't see the rest. I hope this makes sense. Now, let's continue to talk about encryption. I think encryption may be the longest video, but again, encryption is very technical. So learn to pass the exam, and if you are someone who is going to be an actual practitioner, coded person, just do your more digging. This is just to put some light or make it simple for those of us who are just learning to pass the exam, and also to use it, at least get the understanding for work. Next, let's talk about encryption algorithms. Basic understanding. There's symmetric and asymmetric algorithm. This is encryption algorithm, symmetric and asymmetric. Let's talk about symmetric. Or should we talk about asymmetric first? No, you need to know. Let's talk about symmetric algorithm. Symmetric algorithm uses the same key to encrypt and decrypt data. They are both secret. It doesn't mean it's public. Even public keys are secret. It's between the person giving and the person sharing. But symmetric algorithm, they use the same key. So if I'm using dash dash slash slash 125510, you're using dash dash slash slash 125510. So if I am sending you an encrypted data, whatever key I use, private key I use, is the same key I'm going to give to you. It's a secret. It's the same key. It's 12345. You're also receiving 12345. So symmetric algorithm is the use of the same key, the use of the same key to encrypt and decrypt data. Make sense? Asymmetric, you guessed it, is the use of two different keys to encrypt and decrypt data. Two different keys. What I use to encrypt it is not the same key to decrypt it. What I use to hide the message is not the same key I will use to unhide it. Or in this case, it's not the same key you will use to unhide or access the information, the data. Okay, so symmetric is using the same key. Asymmetric is using two different keys to encrypt and decrypt. Obviously, symmetric is faster. Now, how are keys exchanged? In-band key exchange, which is done over the network. Usually, once you use it once, then it's done, you see. Or out-band, which they send by courier or mailbox. Those things don't happen anymore. I think Google still does it, where they send you a key, you come in and you quickly put it in when you're monetized. Yes, I'm monetized, people. So watch all the commercials. I heard that's how I get paid. But when you're monetized, then you go get the key in the mailbox. You come in and then you type it in and you're able to access. I can't remember what I used it for actually. I think you're able to set up your account or verify your account. That's how you verify your account. And then you will have access to your own information. It's kind of, in my opinion, another step for security. So in-band, where it's sent over the network, which I think is more common today. And then out-band, B-A-N, not bound, band, B-A-N-D, where you send the key through a courier or you send a messenger. Do we do that anymore? You send a messenger. I'm sure Ghana still does it, or most parts in Africa will do it. Some parts in Africa will do it. Anyway, so we have talked about types of algorithm. Now we're talking about how the keys are exchanged, usually over the network, where I probably send you a text or you do MFA and then a number is sent to you, and all these things are ways of encrypting data. I actually missed one more. Remember how I talked about the things that you can encrypt? You can encrypt a whole database. Yeah, you can encrypt a whole database that if you just hit this server, anything on the server or any data warehouse, anything on there, nobody can see it except for authorized people with decryption keys. So, or did I say that part already? I'm growing old. I can't remember what I said. And I will begin to post my notes in the comments, because I have realized that when I rant and go on and on and on and on and on, I always miss certain things. So I'm going to begin to post my notes in the comments, and then you can follow along. If you have any questions, read the comments, my description first, and see if I have the notes. I hope I remember. And then you can ask your questions. And please, ask all your questions. There's no dumb question, you see. And the community here, they are so smart. I get private messages about questions people have. And I'm like, why don't you just post it so that other people will see it? People post a question that they already know the answer to, but they feel like other people are asking it because they had to research. So they post it. Anyway, I love you guys. You're so smart. It's unbelievable. I learn from you all the time. All of you emailing me, I learn from you. So stick around and let's learn together. I am going to attempt a wink because I don't know how to do it. And my sister always laughs at me. And some of you have been laughing at me on my Instagram. I always wink, but I don't know how to wink. See you later.